Hey everyone, Agent AGI is an agent framework I built which starts out with a single tool to create, update, and delete other tools. And from there on, it can pretty much accomplish anything. We're going to take a look. Another awesome feature of Agent AGI is that it creates its tool definitions on the fly automatically, so you don't have to worry about it, all that. So let's review how this works and let's demo it. And I will also do a code overview as well. Code files for this is available at my Patreon for Architect Plus members. Link will be in the description. When we first run it, we get a warning message that it can actually auto-generate and execute code and install pip packages. It's asking us to accept this, and we're going to say yes. So currently it only has one tool. It can create tools. So we'll probably need like tools to be able to read files and write files. So let's go ahead and ask it. To ask it to create two tools, one to read files and one to write files. So when we do this, and if you look at its functions, it's going to call that create, update, delete function to create a read file tool, and also going to automatically update at the end the file function definitions. And it's calling its create tool again function and create a write tool. And now it's updating its function definitions. And here we have the definitions for each. So now we can do simple things like I can ask it to read perplexity.txt and explain it to me. Perplexity.txt just contains the sample code from their documentation on how to call the Perplexity Search API. And here it explains it. So it read the tool. So it called its read file tool and read it and explained it to us. So we can ask something like, please create a new tool with this, which can search the web with Perplexity, now that it actually read about this little code snippet. And it created Perplexity Search. If we go back to its functions, it has actually created a web search tool with Perplexity. It also imports certain libraries, and we detect the libraries and actually check if there are any missing pip packages dynamically. And if there is any packages that it's trying to use, then we actually attempt to install it. It works fine for the most part. By the way, a simplified version of this code without voice control and multimodality, it actually, when you run the script, it pops up this window, a PyQt window, which we can use to actually input images to it, which we will review. But a simplified version of this app is available at my Patreon for connoisseur patrons as well. Just keep that in mind. Link will be in the description. So when we run the script, we got this notification that we can type -voice to switch to voice mode. Now, for example, I can do this. When I do that, it's asking me to press enter to start recording, and I press enter to stop. So I'm going to go ahead and ask it something. Can you please tell me what tools you have? And I press enter, and here is the transcription. And it says that it has a create, update, delete function, read file, write file, and Perplexity search along with their descriptions. We can actually quit the voice mode. If it detects the word switch and text in the transcription, it will switch back. Can you please switch back to text? Yeah, and it switched back to text, so it has a voice mode. Let's also see how the multimodal aspect of it works. For example, here I am at LiveKit Docs, which is a WebRTC open source package for live audio and video applications. So I'm just going to take a snapshot of it, I suppose like this. And I can actually paste it here. There we go. And I can go back to Agent AGI and ask, explain this to me. So now it has access to this image. And once it explains, this window will be cleared, so you can add new images. The image shows instructions for creating a page in web app using LiveKit. You can also upload images. You can drag images in here too. So let's go ahead and upload, for example, this one. This is the limited version thumbnail for Agent AGI. I can also actually go to my downloads and drag in other images as well, as well as being able to paste. Then I can again say explain these, and now it should actually explain these images to me. There we go. It's explaining each image, mark this limited version and whatnot, and this window clears up. So, but remember we added its web search functionality. Let's actually use it. Remember we added the web search tool, Perplexity. I can ask something like, please search for the latest LLM related news and save the summary of it to a file. Remember now it has web search tool, which it wants to use, and it has a write file tool. So it's going to first call Perplexity, of course, keeping in mind that it's automatically calling the Perplexity API key from environment variables. Make sure you have that set up. And once it gets its response, then it's actually going to write a summary of it, the file, and it'll probably going to respond to us as well. And it tells us that it wrote it to LLM news summary.txt. And here, there we go. We actually get to see a summary, and it explains its actions to us. So quite a lot is possible. I have this tests here. So it's actually like, let's try this, write a tic-tac-toe game to a file, but also create a tool which will run the game and return if there are any errors. Let's try to get this working. I'm curious what it'll do. So when you're asking a complex thing, it's best to actually spell it out. For example, perhaps we are saying write a tic-tac-toe game to file. So we are hoping it'll use this write file tool. Just keep that in mind. When you have a complex use case, okay, we actually ran into Anthropic's content filtering policy for some reason, and I should add better error checking. I'll remember that. But we can actually rerun the script, and it'll have all the previous functionality. This didn't happen before. Let's try it one more time. I tested this last night and it worked fine, but okay. See, it wants to use this write file tool to create a tic-tac-toe.py, which it did. And it also wanted to create a run tic-tac-toe game function. Let's go ahead and take a look at it. There we go. It's going to try to run. And now it's trying to run the tic-tac-toe game. There we go. It actually ran it. And I asked it to run it again. It only runs it for 5 seconds. We can actually change this timeout. So, okay, this is a good opportunity for us to use the update functionality. So it is this run tic-tac-toe game, which is going to run the tic-tac-toe.py, but only for 5 seconds using subprocess. Okay, I'm going to ask it to update the tic-tac-toe runner tool to run the game for 20 seconds. Now, I can actually go ahead and manually update this, and everything will be updated for us automatically. I can also add functions or tools manually myself. Just so you know, just when you're doing that, make sure to put 5 hashtag symbols in between each function. That's how the script is detecting them. Anyway, let's ask it to update the tic-tac-toe runner tool. Let's see if it'll actually use its creation tool in update mode. And as you can see now, it's updating, it's calling its create update delete tool with the mode update. So now, if you take a look at it, it has updated this tool to timeout in 20 seconds. And now it's actually running it again. And here is the game. You can now play this game. There we go. If there was any errors, then this would have returned any errors. And then the agent AGI will have a chance to actually correct it. So quite, as you can see, quite a lot is possible. Really, your imagination is the limit. Sky is the limit, I guess. Creates his own tools. You can create your own tools as well, custom. You can update tools manually, or you can ask it to update it. You can also ask it to delete the last 2 tools you have created. Let's see if it'll understand this. Okay, it actually created all the. Okay, no, it just deleted the last 2. Let's see. Oh, it also deleted the write file tool, but okay, it made a slight mistake, but nevertheless, this can be improved, I feel like, by changing the system message we'll review. So this is more or less how it works. If you want to know more about it, you can check out my other videos on this too, Agent AGI, the original video, and the Agent AGI with Vision, Financial Analyst. In these, I go into more in-depth demos. For the rest of this video, we'll actually be reviewing the code. And you can find these videos at my website, ecohive.live, along with my YouTube channel. And while you're there, take a look around. I have over 300 videos that you may find interesting. It also has a quick search functionality. I would like to take a moment to talk about the benefits of becoming a patron. As some of you may know, in the last year and a half, I've spent 3,000 hours, over 300 projects. As a patron, you will have access to all the code files so you can get inspiration and iterate quickly. Another benefit is that you'll have access to all my courses. And my most recent and most proud one, the 1000x Masterclass, teaching what I've learned on how to code fast and efficiently. Also the Streamlit course and the Fast API course. In my Patreon, I also have tiers in which you can connect with me one-on-one. Check those out as well. So how Agent AGI works is through multiple files. The agent multitool multimodal.py is the main entry function file, I should say. And then there we have functions.py, which contains the original create, update, delete function, along with any other functions that it can create or you can add here manually. Helpers.py has some helper functions such as reading agent instruct, loading messages, saving messages, also the image upload window using PyQt, and recording audio, which we will overview. And it also automatically creates tool definitions.json for each new tool that it may have. I forgot to mention that there's also agent instructions.txt. So you can, if you want it, you can actually add here more complex instructions. I'll demonstrate. So I just went to OpenAI's documentation and just grabbed a quick chat completions call along with how it's completed. So I can actually say, please create a tool which can talk with an OpenAI model. Okay, and it automatically reads from agent instructions and moves them to older agent instructions just in case if you'll need them again. And now it's actually creating a chat with OpenAI tool. If you go ahead and see, it's using GPT Turbo, but we can change this to GPT 4.0. And next time we ask it, get GPT, let's say get GPT to, or well, let's review the tool definitions and see what it said, because this is important. You can update the tool definitions too. Just don't just only update the descriptions. So it says OpenAI's chat models. We can perhaps say GPT here. So then we can say, ask GPT to tell us a joke. And remember, we had changed the model name here, so it's automatically updating because it detected a change. And tool definitions are updated as well. And it is using chat with OpenAI to get a joke. So you can actually, so what we did is we added complex instructions into agent instructions.txt, right? And then we allowed it to create a tool with that. So if a single line instruction or a terminal is not sufficient, you can actually use this too. So this is part of the program, and older agent instructions is where it copies the file to, just in case. And of course, the requirements. So I did include this Wikipedia and archive because I was using these in previous video demonstrations. So these are not necessary, but these are the tools that you need. So let's maybe start with the main loop. So if you scroll all the way down, we have a chat function here. This is the main chatbot function. We pretty much, we are not actually using this last modified time. This was from a previous version, but I just left it there. Anyway, we create a messages file. If you control click on it, this just opens and creates a message.json file. And then we have update tool definitions. Oh, yes, I forgot to mention it also has the function definer GPT, which actually is responsible for defining the function definitions that uses GPT for. But update tool definitions actually has a extract functions function in it, which finds all the functions and looks for the functions in themselves and tries to create function definitions for and then update the tool definitions. With that, in the tool definitions.json, it's quite long. We'll actually take a look at it, but that is what happens at that time. And then we print a welcome message and a warning message that this can create and execute code and install packages, that it is that you should take into consideration that it can be dangerous, and asks you if you want to go ahead or not. And then we print that by typing dash voice, you can enter the voice mode, and you press enter to speak in voice mode. We start with voice mode false. And we have imported the image upload window from helpers. We initialize it. That is for multimodal, right? To be able to input voice inputs, image inputs. And then we enter a while true loop. And we call the update tool definitions again. We are not using the last modified time, but I haven't changed that yet. So if it's in the voice mode, we ask user to press enter to start recording. And then we look for that. If that is so, then we say that press enter to stop, and we call the record audio function from helpers.py. Then We get the user input with the using the transcribe audio function, which is again in the helpers.py, which we'll review. And then we also check if in the transcribe user input switch and text is present, then we set voice mode to false. And if within this while loop, then we'll go back to taking user input as text. Otherwise, if the user didn't choose voice mode, then we're taking user input regularly. And here, if the user has entered dash voice, then that is here we do the switching. And we at this point we also look for image content if it was any present in this window. And this actually creates the proper form that Anthropic accepts. And as image content, this function does that itself, which we're going to review. And now we just simply call the answer question function with user input, the messages, and the image content. Pretty much, and then we just save messages. So most of the stuff happens in answer questions here, which actually is a very long system message and actually updates the tool definitions, adds the image content along with the user text message content, if any. And then we ensure some stuff here because Anthropic's API doesn't accept two consecutive same roles in the message. So we check to alleviate that issue. And then we just simply make a call, check for tool usage, and then we call the tool usage stuff, execute it if possible, and then we get a tool response. So that's what happens, and we update the tool definitions every step of the way. So because the model can write its own tools as well. So this is pretty much like an overview. So now let me go ahead and explain different parts of the code. So let's start with perhaps reviewing the helpers, because this is what we use throughout the functioning of the agent AGI. But remember that you can download the code files for agent AGI, the full version as an Architect Plus by Patron. Link is in the description. And if you wanted only the limited version without voice control or multimodality, and a limited create tool, original create tool, I should say, that's also available at a $30 level. Link will be for that in the description as well. So the helpers consist of just helper functions like such as read agent instructions from agent instructions.txt, as we have looked at. So try to read it and then transfer the contents of agent instructions to older agent instructions and return content. Load messages actually loads conversations through from messages. We're not really using this. I was intending that allow agent AGI to modify its own message history, but then later I gave up on it. Save messages is actually how we are actually saving the messages to JSON so we can actually observe. So this is like our message history with all the tools executed and stuff. This load tool definitions is to be able to load the tool definitions from the JSON. Load tool definitions.json, create message file. This is to create the messages.json in the beginning of the script. Create required files is to actually create the agent instructions and tool definitions in the beginning of the script. Now, here we have the sanitized search term. I actually forgot what we were using this for. I think that I was using this for archive search and stuff like that. I left it here, but I don't think we're using it. Next up is the PyQt window for multimodality for input images. I got a lot of help from Sonnet, so I don't know exactly how PyQt works, but this essentially sets up an image window with initialization. It accepts drag events and drop events, so we can drag and drop images into this. We can upload images and we can add images, right? This method, and we create the proper type of Anthropic schema for dealing with images, which we will return and insert into messages. Also, ability to remove selected images, to clear images, and key press event that is for Control C and Control V, paste. Process image, pretty much, yeah. So roughly, this is just for the functionality of dealing with the image window. The record audio uses PyAudio to actually record the user input. Pretty much that's all it does, and saves it to file speech.mp3, which we then use in our main process to call OpenAI's Whisper for transcription, which is right here. This takes in a file path and actually calls Whisper1. and returns the text of the transcription. Now, I also have a GPT helper. This is a general helper method, which takes in a system message and an optional user message. This uses JSON mode with GPT-4o. This I used in the process of actually determining the proper package names for the pip installs. If I can quickly jump into, yeah, so the create and update delete function actually uses this tool, so the GPT helper, because we try to detect the imports that it is using in its functions. If you scroll down, we'll see that, for example, for Perplexity Search, it's importing OpenAI, right? So in its original create, update, delete function, we are trying to detect these imports. Sometimes you don't install a package directly by its name. For example, Pillow is a good example. You import Pillow as PIL, right? But actually it's installed as Pillow like this. So detecting it dynamically like that then had an issue. So I created this GPT helper to return the proper PyPy names, which we can use the pip install. So it returns a list. We detect the imports as a list, so it returns a list. That's why I use JSON mode. So this is where I am using, and then we use subprocess to install those packages. This still, has issues sometimes, but for the most part, this was a better approach than just going using this. It just improved the flow of the script so much better. But this is what I'm using this helper for. But if you decide to download the code, and you can actually use this in many different places, since it's very generalizable, just takes in a custom system message, user message. Yeah, you can specify a schema, as I have done here in the system message. Yeah, so just keep that in mind. So its create, update, delete function is the most important. This actually creates, updates, and deletes new tools for the agent. So it takes in a function name and actually the full function code, and it is mode. You can have mode add, update, and delete. So if it's mode add, then we find all the imports in the function that is being passed, function code that is being passed to this. Then we run the GPT helper to get the proper imports. Then we try to install those, and we get the installed packages. Oh, sorry. Actually, we first try to get, so it's a multi-step process. We first try to get what is currently installed. So we detect the imports from the function code for the new tool, and then we get the installed packages by running pip list. So these are the packages that are already installed. And we also detect the standard packages that are in Python, because sometimes, for example, random module is a standard Python package and a tool might need that and import it, but we can't install that. It's not a pip package, it's a standard. So we're detecting the installed packages and the standard packages. And we also detect the modules in the current directory. For example, this agent AGI, because of its open-ended nature, can actually import and use one of its helper functions. Okay, you can ask it to read the helpers.py and create, for example, a tool in functions.py that uses, for example, the GPT helper. So in that case, that becomes a module, because we can't import helpers as saying import helpers, or from helpers import GPT underscore helper. So that's why we're also detecting that. So we're detecting three things, and then we compare and find the missing packages, and then we print it to the user and ask if they want to install them, because you don't want to install improper PyPy packages. So always make sure to double check. If that's the case, we continue and install them. And after that, we write the function to the file, which is this file. So that's why we're saying the underscore file underscore, which is because we are referring to the file itself. And then we call function definer to get a new tool definition. And then we open tool definitions and add it there. If it's the mode update, then we try to find the function using its function name. But when we find it, we also find a preceding and continuing 5 hashtags. So that's going to define where the function starts and ends. If you look at one of the functions, these are important. The reason why this was important is because if you try to detect just with the function name, it's difficult to detect the imports. And secondly, it's difficult to detect where the function ends. So I came up with a strategy like this. So we find the function start and end. And we also, so this we replaced the old function, but we also do some checks to make sure that these are actually removed properly. Like we remove the ending, 5 hashtags and keep the beginning one, for example. And if it's the mode delete, we pretty much do the same thing, but instead this time we just remove it and then we write the file back in. And the rest of the functions are the ones that we have created while we were using. Now, another important part is the function definer GPT. So this I originally created, so I was thinking of a much more manual approach. I thought, okay, well, I'll just define my own functions. All I needed was actually to create the tool definitions. So I thought I'll just run this file and create the tool definitions and then use the agent. But then it became so much more dynamic. This takes in a function name and a function and actually detects the functions using some built-in Python stuff by looking in the globals.items and check the functions. And we get the source code for the function using inspect. So once we determine the functions, then we're going to make a call to GPT-4o to return the definition for it. So we give a hefty system message. We say you're a world-class tool definer, and we give it a sample function along with its definition. I have 2 examples here. You can add more examples, and I give some additional instructions. And then we hope that we're using JSON mode, and we hope it returns a proper JSON definition. Most of the time it works. The one thing that I had to specify, do not include an output schema, which it was doing occasionally. It's actually fixed a lot of errors. Once we get the function definition, we simply write it. But we don't use the main here. So this is when I was imagining this to be much more static. We actually call this create tool definition and use it throughout the main file. So in the main file, we are actually importing all the helpers and we are importing, so these are what we're going to use. We also import Q application to be able to use the PyQt window. There's quite a lot of descriptions here. I tried to make it self-explanatory. This script uses entirely Anthropic, so we initialize Anthropic with the Anthropic API key. Do remember that the function definer uses GPT-4o and you have to initialize your OpenAI client with your API key in there as well. So we call create required files, create message files, and load tool definitions to create the agent instructions, the messages, and the tool definitions, etc. And we load the tool definitions. We are not really using last modified. And now we have the update tool definitions, which we run on occasion. Here's the old version of trying to do this. So we need to detect all the functions from functions.py. And we also create a function snapshot, which we can compare if a new tool has been added. And we extract the function definitions from a string of a Python code from the functions.py file. So by looking at the def line and by extracting the function name and parameters, and we continue capturing the body of the functions. So this it's pretty complex, and I got a lot of help with from 3.5 Sonnet. But this actually returns us a function, and it returns it. And this is a function defined under the update tool definition. So we have defined update tool definitions, and we defined extract functions function under it. And we do have to say that tools are global. And here we then open the functions. We do create a snapshot. Okay, so we copy the contents of the functions into the snapshot, and we load the tool names from the JSON file. And then now we can actually compare. We extract the functions from the current functions and the previous functions because the previous content is in the snapshot file, the functions underscore snapshot. So then we check, well, if the tool name that we currently have isn't in the current functions. We first remove the tool definitions from JSON that are no longer in the current functions. And we get a current list of tools and we loop over them for the tools to actually generate, and we call the create tool definitions on it. And then once we have it, we update the tool definitions JSON. And we also compare if the current functions is not exactly the same as previous function, then we reload the functions to get the latest changes. Then we loop over the tools and we do some comparisons. And if there is any changes, then we call the create tool definition again to get a new tool definition. And then we append it to the updated tool. And this is also just to add the new functions as tools. Then we simply again save it to file and update the snapshot file. Here we have another helper. I could have possibly moved this to helpers, but I wasn't sure because I'm not too exactly sure on how the globals work. So I left it here, but this is the process the tool goes. It actually gets a tool name and then actually uh, executes a tool call with the given name and input. This is when Claude calls a tool name. Then we detect it from the globals and execute it with the tool input. Then we have our main function, answer questions, which takes in a user messages and image content, if there is any. It processes user questions, potentially uses tools, and generates a response. Pay attention, we are again using the tools as global. The system prompt, you can use some real improvement, but essentially you can read, pause and read it, but I wanted to give it the ability to actually create its own tools, even without user explicitly saying it. Uh, but I did try to say when creating tools, create the simplest possible tool. You know, essentially, I think the system message needs a lot of work, and I'll be working. So we here at this point we read agent instructions using the helper method. If there is an agent instructions and agent instructions.txt, then we create a prompt, answer the following question. This is the user input. But then if there is any agent instructions, we add it here. And when answering the questions, we wanted to return it into XML text as your answer. So you can actually reason about it too. So this is what we display to the user. If there is, and we update the tool definitions here, just in case. If there is any image content, then we append it to the messages. Uh, because the user messages can include regular text messages and also images, right? And when we enter the while loop, we make sure that no consecutive assistant or user roles exist in the messages. And if there is, then we insert the opposite role with just three dots. Otherwise, Anthropic will return an error. In OpenAI's API, you can actually send two user messages in a row or two assistant, but not with Anthropic. So at this point, we are actually calling the Claude 3.5 Sonnet API with the system prompt messages and the tool definitions, which we are automatically creating dynamically from we are grabbing the tool definitions, that is. So if the agent responds with regular answer, it's not a tool used, and we look for the answer in between the answer XML tags and pretty much append it to the messages and return it. If it's tool used, then we engage in the loop for executing parallel tool calls because agent actually can call multiple calls within the same call. If you'd like to learn more about that, you can actually watch my tool calling deep dive with Anthropic API, this video right here. You can find it on my website, ecohive.live, or at my YouTube channel. But this really goes into depth on how to do tool calling of from a simple case to a more complex case. But pretty much we check for the tools and we grab the tool name and tool input. Tool input can be quite long, so we are actually truncating it to 80 characters. If you go back up, this is why this tool input is right here. All of this, and it's truncated with three dots in the end. We do to this, and we print Claude wants to use whatever tool with the input. This is the truncation. And we call the tool with the process tool call, which we looked at with the tool name and the tool input. If there's any error, we grab the error and we assign it to tool result, and then we create a tool response. So whether the tool completed successfully or with an error, we give it back to Claude, right? As a user of type tool with the ID and also the tool result, and then we append it. And because the tool response can actually include a call to actually create a new tool, we also update the tool definition. So that's it. The rest of it is I handle with the helper functions and update tool definitions. And we have all already talked about the chatbot loop part of it. So this is it. I hope you enjoyed this. I hope I did a good job explaining it. But you can also download the code from my Patreon. You can grab the full code, the multimodal code with voice instructions, voice commands from if you become or if you are an Architect Plus level patron, link will be in the description. It is a simplified version available for connoisseur level patrons, 30 plus, $30. Also, if you'd like to speak to me one-on-one as a consultation, or if you have any questions, or if you need help with your projects, I have tiers to do that for 1 hour every month and 3 hours every month. You can find those at the membership and my Patreon as well. Also, I have Ask Me Anything sessions with Architect Plus patrons. The next one is going to be this Sunday at 9 p.m. I try to do these every week. They're very useful. You can find a link to that in the description as well. I also started posting much more on Twitter X, as you can find me at hive_echo. I post exclusive videos and posts here as well. So all in all, thank you for watching, and I'll see you in the next video. I would like to take a moment to talk about the benefits of becoming a patron. As some of you may know, in the last year and a half, I've spent 3,000 hours, over 300 projects. As a patron, you will have access to all the code files so you can get inspiration and iterate quickly. Another benefit is that you'll have access to all my courses. And my most recent and most proud one, the 1000x Masterclass, teaching what I've learned on how to code fast and efficiently. Also the Streamlit course and the Fast API course. In my Patreon, I also have tiers in which you can connect with me one-on-one. Check those out as well.